Hi, my name is Gina, and I'm going to be talking today about the hypothesis testing for the mean using large samples. The null hypothesis, H sub 0, is a commonly accepted fact. It contains a statement of equality, such as less than or equal to, or greater than or equal to. The alternative hypothesis, H sub A, is the opposite of the null hypothesis. Its statement must be true if H sub 0 is false. It contains a statement of inequality such as less than, not equal to, or greater than. When you write your null and alternative hypotheses, you translate your claim into one of the following statements. So you have your null hypothesis is mu, that is less than or equal to k. Your alternative is mu is greater than k. So for each of these, your null hypothesis shows your equality, such as here, and your alternative hypothesis shows your inequality. For example, given a set of 106 healthy body temperatures where the mean was 98.2 degrees with a standard deviation of 0.62 degrees at the 0.05 significance level, test the claim that the mean body temperature of all healthy adults is equal to 98.6 degrees. So I'm going to continue to use this example throughout the video, breaking it down into different sections. So for this, we want to write the null and alternative hypothesis as a mathematical statement. So viewing your example again, you see that it states equal to 98.6 degrees. So therefore, this is what you will be using. So you have your null hypothesis equals 98.6 and your alternative is not equal to 98.6. Then you want to state your claim. Since it's equal to 98.6, your claim is going to be your null hypothesis. Your rejected regions. If your alternative hypothesis, H sub A, contains less than, your region will be left-tailed. So your left tail is going to be towards your left side, and it's what is rejected. If your alternative hypothesis H sub A contains a greater than, your region will be right-tailed. So your right-tailed is your rejected region, I should say. And if your alternative hypothesis H sub A contains a not equal to, your region will be two-tailed. So you're going to have one on negative and one positive rejected region. So using the previous problem, decide whether to use a left-tailed, right-tailed, or two-tailed test. So your claim is your null hypothesis is equal to 98.6, and then your alternative hypothesis is not equal to 98.6. So since we are using is not equal to, it is going to be a two-tailed test. Your p-value is used as an alternative to rejection points to provide the smallest level of significance at which the null hypothesis would be rejected. So if p is less than or equal to alpha, then you reject your null hypothesis. If p is greater than your alpha, then you fail to reject your null hypothesis. For a left-tailed test, p equals the area in the left of the tail. For a right-tailed test, p equals the area in the right of the tail. And for a two-tailed test, p equals 2 times the area in the tail of the test statistic. So for example, looking back to the previous example, use the p-value to either reject or fail the claim. Reject or fail, I'm sorry. So you want to look at what you already know. So you know alpha is 0.05, and it's a two-tailed test. That means it's going to have two values, one negative and one positive. For a two-tailed test, you find your p-value by doing alpha divided by 2. So you have 0.05 divided by 2 is equal to 0.025. So next you want to use your standard normal distribution chart to find your values. I didn't put the whole chart in because I couldn't find one small enough, so we're going to use 0.205 is located here, so it's going to be negative 0.9, and your top value is 6. So you're going to have a negative 1.96 and a 1.96. Your z-test can be used when the population is normal and sigma is known, or when the sample size is at least 30. The test statistic can be found by using the formula z equals x bar minus mu over sigma divided by the square root of n. So using your previous problem, you want to calculate the test statistic. So now you want to look at the information that you already know. So you have your formula. You know that x bar is 98.2. Mu is 98.6. Your sigma is 0.62. And your n is 106. And you're going to want to plug your information into the given formula. So next you want to solve. When you do this on your calculator, you get that z equals negative 6.64. So what we already know is that it's a two-tailed test. I have to fix that, with critical values of negative 1.96, 1.96, and we also know that z is negative 6.64. So here I have a blank curve, and we're going to go through how to set this up. So first, on this side, you have your value of your negative 1.96, and then your other side, we have 1.96. So these are going to be your rejected regions. And sorry, I shaded them in as best as I could. Then your value of z equals negative 6.64 is all the way at the end. But you can tell that is in your rejected region because it is located in this region. So we're going to state that you reject your null hypothesis, and there is enough evidence to reject the claim that the mean body temperatures of healthy adults is equal to 98.6. I hope I explained that to the best of my ability, and I hope you enjoyed.